Good evening, students. So today we are going to discuss about the new topic, that is concentration terms. So hope the previous lessons were clear for you. Hope that there will not be much doubts from your side. Okay, so as you can see from the thumbnail that today we are going to discuss about the concentration terms, right? Okay, so before starting into the lesson, I would like to know about the quality of broadcast. Please let me know how it works, and in out of 10 how much you can give it for the quality. If there is any problem, it works as a feedback for us so that we can work on its quality and bring up with the much more quality videos for you people, right? Okay, now okay, right now here you know who I am. Okay, we have been seeing for the past one or two classes, one for NEET I have taken and the other one for JEE students. So my name is Roshan Ahamed. I'm a MTech graduate and was a National Olympiad winner, and with the 6 years of experience I have in this field. Okay, right. Now students, today we will be discussing about one of the most common topics from mole concept or some basic concepts of chemistry, that is concentration terms. So Vanshika is asking to buy the course. To buy the course you can contact us, okay, as well as it's happy to hear that everything is best. Okay, good Vanshika, right? Okay students, now let's see, you will be having free classes regularly in our YouTube channel. You know that very well, and you can, if you have not subscribed to our channel, you can please subscribe to our channel so that you will get high quality content free of cost, and which will help you to score very good marks for your upcoming exams. Okay, yes. Okay students, now coming back to the topic, today we are going to discuss about the concentration terms, especially 4 major concentration terms. The very first one we discuss about the molarity. Okay, and molarity we denote it by capital M. You can see it here, we denote the molarity in capital M. Okay, so students, what do you mean by molarity? So before getting into molarity, let me ask you a question. Why we are using concentration terms? You know that solutions, the strength of the solutions are measured or are determined by using concentration terms. Without concentration terms, we do not know whether a particular acid is strong or weak or dilute, etc. So actually these concentration terms are connected with the solutions where you have one solvent and you add certain solute into it. Okay, so concentration terms are generally we give it for solutions. Okay, we discuss for solutions. So if I am having a particular solution and if I want to represent the strength of that solution, then I have to use certain concentration terms in order to make understand other people what the strength of the that particular solution is. So here we are going to discuss about the 4 major concentration terms. That is, one is molarity, which is the most common one, and then we discuss about molality. Then we will be discussing about normality, which is much more important when it comes to ionic equilibrium section, where you mixes 2 acids or weak acid, strong base, or strong acid, weak base. In such scenarios we normally use normality as the concentration term. Then we will discuss about the mole fraction, and mole fraction also have certain applications in states of matter we use, where Dalton's law of gases, as well as in the chapter solutions also we use this mole fraction in solubility, Henry's law, and also in Raoult's law also we uses this mole fraction. So you must know all these concentration terms, then only it will be easier for you when you start studying all those topics which I have just mentioned. Okay, so let's start from the basics, and the very first one, that is molarity. So see students, so how we are going to represent, or how we are going to measure the concentration of a solution. First, let's discuss what a solution is. See, I have considered a container in which it consists of water. Say because I'm taking water because it is the universal solvent. Okay, so it's a solvent. I have taken water, and if I add some solute into it, that is, say, NaCl. Okay, so NaCl, and now the solvent has converted into solution. Okay, so what is solution? You can say that solution is a combination of solute and solvent. So whenever you have a mixture of solute and solvent, you call it as a solution. So I wanted to measure, or I wanted to understand the concentration of solution. How I am going to understand the concentration of solution? See, there I have to use any of the concentration terms. So let's discuss about that. What is molarity? How I am going to measure the concentration in molarity? It is simply but number of moles of solute in 1 liter of solution. Say, if I consider 1 liter solution, this is 1 liter solution. Okay, and I wanted to know the concentration of this solution. How I am going to consider it? See, you must know what moles of solute you have added. So the number of moles of solute divided by volume of solution, it is volume of solution in liter. That means you take 1 liter and identify how many moles of solute is present in that 1 liter, and if you divide that number of moles of solute with the volume of solution, you will get the proper molarity value. Okay, hope this is clear. So you can just understand the concept of molarity as number of moles of solute. Sorry for that. Yes. Okay. Okay. Number of moles of solute divided by volume of solution in liters. Now see students, I have given you, from this basic definition, I have given you 3 equations. What are they? The very first one is molarity is equal to number of moles of solute, means N, divided by volume of solution in liters. So here it is volume of solution, and understand it is not volume of solvent. Okay, next one, now you can convert this number of moles of solute into weight by molar mass, which we have studied in the previous class, right? Number of moles is equal to weight divided by molar mass. So for solute, we generally use the term, we generally use the number 2. Okay, for solvent we generally use the number 1. So if I write W2 means weight of solute, it means just weight of solute, by M2. M2 means it is weight of molar mass of solute. Okay, into volume. Okay, so now molarity have another equation. What we have done here, we have just replaced the number of moles N with the formula N is equal to W2 by M2. What is N? Number of moles can be represented as weight of the particle divided by the molar mass of the particle, right? So W2 by M2 into V, you can represent it that way. So the third representation is, if the question is given in ml, if the question is given in ml, then how you are going to represent that? If the question is given in ml, we know that 1000 ml will give you 1 liter. So here I can write W2 divided by M2 into V. Here I can write 1000. Why should I write 1000? If the volume is given in ml, then you have to convert it into liters. So it will we have in the process of conversion, how we are going to convert ml into liter? Divide it by 1000. So that 1000 will go to the numerator. Now the equation becomes W2 into 1000 divided by m2 into volume in ml. So hope that is clear for you. So there are three equations to understand the molarity. The very first one is molarity is equal to number of moles by volume of solution in liters. Remember, it is solution. And the second one is molarity is equal to, you can change that number of moles. See, why you have to change the number of moles? Maybe in certain questions, they will not give you the number of moles. Instead of giving the number of moles, they just say this much gram of NaCl is used or this much gram of H2SO4 is added. So in that case, you have to find out the number of moles, or you can use the second equation, that is W2 by M2, which is equal to the number of moles of solute into V in liters. And in certain question, the solution, the volume of solution will be given in ml. In such case, you have to multiply the numerator with 1000 in order to find the molarity. Hope this is clear for you students. Okay. Now let's move on to the next one. Here, this is a very important question, and this is a very important note actually. And from this note, it repeatedly asked a question for JEE mains as well as for NEET also. Okay. What was the question? See, from among the concentration terms, they have asked which of the following concentration terms will change when temperature is changed. So you have to understand that molarity depends on temperature. How it depends? The issue is molarity changes with respect to change in temperature. How it is changing? This is what you have to understand. See, from the equation, come back to the equation. What is the equation for molarity? Molarity is equal to number of moles by volume. That means molarity is inversely proportional to volume. So if you change the temperature, if you increase the temperature, the expansion takes place and the volume increases. From the ideal gas equation, we know that PV is equal to nRT, where V directly proportional to T. Here, even though this is ideal gas equation, but here we are considering what? Here we are considering solution. Even then it is applicable to solution also. That is, volume is directly proportional to temperature. As you increases the temperature, the van der Waals forces between the molecules is broken and molecules are more free to move. That means they have expanded. That means the volume has increased. Okay. So here, as the molarity is inversely proportional to volume and volume directly depends on temperature, we can say that molarity is dependent on temperature. So molarity of a solution depends upon temperature because volume of a solution is temperature dependent, and you have to understand this. This is a very important point. Okay students, and I have told you that from this very point there have been asked many questions in the previous years of JEE mains as well as in NEET. Okay, so we'll move on to the next. Now the second one is molality. Dear students, from each concentration terms, you have to understand what is the difference between these two. Okay, now what about molality? Okay, I have told you all the concentration terms are used in the case of solutions. Solutions means it consists of solute as well as solvent. So let me consider another solution. Here I have filled it with water. So what is water? Water is our solvent. Okay, water is our solvent, and I am adding certain amount of solute, and let solute be NaCl, sodium chloride, right? Okay, now see how we are going to find out the molality. It is simple, that molality M is equal to, see, molarity we represent it by capital M and molality we represent it by small m. Okay, so molality is equal to number of moles of solute divided by, see here it is mass of solvent. It is mass of solvent in kilogram. It is not volume. It is not volume of solution, or here it is not mass of solution. See, clearly understand this point. It is mass of solvent. So what is molality? Molality equal to number of moles of solute, similar to what we have studied in molarity. Molarity also, it is number of moles of solute, but in the denominator the term has changed. In the case of molarity, the denominator was volume of solution in liter. Here it is weight of solvent in kilogram. So that difference you have to keep in mind. It is very important. So molality M is equal to number of moles. We always represent the solute number of moles or the solute as 2 divided by weight of solvent. We will put it as 1 in kilogram. And now we can make changes to this equation by number of moles can be changed into weight by molar mass, right? We have studied in the previous class. So N2 equal to weight of solute by molar mass of solute into weight of solvent in kilogram. In certain question here I have to write it as M2 because it indicates the molar mass of solute. Okay. Now if the weight is given in grams, then you convert, in order to convert into kilogram, you have to divide by 1000 and that 1000 will go to the numerator. So your equation becomes W2 into 1000 divided by M2, that is molar mass of solute, into V1, that is weight of solvent in gram. If it is given in gram, then this is the formula you have to use. So these 3 formulas you have to learn from molality, and 3 formulas I have given you from molarity. Both these 2 you have to learn with proper care. Okay. Yes. Now another point, another note. See students, molality of a solution does not change with temperature since the mass remains unchanged with the temperature. See, we know that the molality is inversely proportional to the weight of solvent. It is not depending on the volume. Here in the case of molality, we are not taking volume into consideration. We only depend on the weight of the solvent, and molality is measured in with respect to weight of solvent. Is that clear? Yes. Okay. So we know that if you increase the temperature or if you decrease the temperature, does the weight changes? No, absolutely no, right? The weight of a particular solvent or solute will always be constant and it does not depend on the temperature. Hope that is clear. So there is a point in NCERT textbook. So which of the concentration terms is better to use, whether it is molarity or molality? I would say molality is the better one to choose, because we know that if you measure a particular concentration of a solution and you keep it in your lab, we know that the seasons will change. We have summer season, we have winter season, so the room temperature changes. So if changes happens to the room temperature, then obviously if the temperature changes, then obviously the volume changes, right? There will be expansions. So the molarity changes, value of molarity changes. But if you have find out the concentration in terms of molality where we use weight, okay, it doesn't change with change in temperature. So that concentration value will be constant even if temperature changes. So we choose molality as the best option to represent the concentration. Hope that is clear for you, students. Now let's move on to the next one. See, this is the very important formula that you have to study. That means, see, in the JEE mains or JEE advanced or NEET, wherever you look, from concentration terms, the conversion problems are asked, especially the conversion of from molarity to molality by giving density, or molality to molarity by giving density. So the relationship between molarity, this is molarity, this capital M is molarity, and here you can see molality, and density is very, very, very important. And if you know this simple equation, and this is a simple equation, if you are asked to find out either molarity or molality by giving the density, then if you can use this equation, it will make your calculation so easy. So let me introduce these terms to you. Here density D, small d of SOL means it just means density of solution, and we generally take density of solution in gram per centimeter cube, right? Yes, sorry, gram per ml, not centimeter cube, it is gram per ml. Yeah, okay. Gram per ml. Okay. Now, what is capital M? Capital M is nothing but the molarity of the given solution. Molarity of solution. Now, what is M2? I have told you the 2 number indicates what? It indicates the solute. So, here M2 means molar mass of solute. Molar mass of solute. Now, what about the small letter m? Small letter m just indicates the molality of solution. Molality of solution. Okay. Now, this is all about this formula, and I am again giving you, and I am again stressing on this point. This formula is very, very, very important. This will make your calculation so simple, because normally in the competitive exam you can see that the conversion questions are so dear to the exam paper setters. Okay, so you have to learn this, you have to use these equations, practice it more and more, so that you can easily answer the questions when it comes in your exam. Okay, now students, if you have not yet joined our Telegram group, you can easily join our Telegram group. You can just scan the QR code given in the back side of me, and let's join there, because you will be getting PDF materials, you will be giving the free classes will be recorded and it will be uploaded there, and we will have the announcements and any special classes or any sessions. All the announcements will be given in the Telegram group, and also we will give you notification regarding the discounts and prizes that you have won with the journey you have with the APJ Academy. So it's very important you join our Telegram group. Okay students, now let's move on to the next one. So here is an interesting question. So let's do this question. Calculate the molality of KCl solution prepared by dissolving 7.45 gram of KCl in 500 ml of solution. See, this is a previous year question. So let's see, the density is given as 1.2 gram per ml. Okay, the density is given. Now we have to find out the molality is what we have to find out, and it is given that the solute, the mass of solute, that is weight of solute, is given as 7.45 gram, and we know that the compound given, that is solute, is KCl. Now can we find out the molar mass of KCl? Molar mass of KCl is what? We know that potassium. What is the mass of potassium? You know that the mass of potassium is 39 and mass of Cl is 35.5, right? So mass of potassium is 39 plus 35.5. So what will be the value? 69 and 74.5. 74.5 gram per mole is the molar mass of KCl. Yes? Okay. Now, what we have to find is, we have to find out the molality. Density is given. So let's calculate the molar mass, sorry, molarity. Molarity of the solution is, here we can see that the volume is given in 500 ml. So we know the equation is W2 into 1000 divided by M2 into volume of solution, that is 500 ml. So here W2 is 7.45 and M2 is 74.5 into 1000 divided by 500 is equal to 2. Now if you cancel this, you will get a 10 below, and if you can cancel this, you will get a 5 here. So molarity is equal to 1 by 5. Okay. Now what's the formula we have? That is, density of solution is equal to molarity into M2, right? That is molar mass of solute divided by 1000 plus 1 by molality. Now just substitute the values we have. that is 1.2 equal to molarity, we just find it out as 1/5 into molar mass of solute is 74.5 divided by 1000 plus 1/m. Now 1.5 into 1.2 into 5, 1.2 into 5 is how much? 6, I think so, right? 1.2 into 5, 10, 5, 1, 5, 6, yes, 6 is equal to 0.0745 plus 1/m. So you can write it as, now let me take the next page, sorry. So 1/m is equal to 6 minus 0.0745, that is equal to yes, how much? 6 minus 6.0000 minus 0.0745. We have to subtract it. Here you will get 5. Here it's 9, 9, 9, 9 and one more 10. Okay, so it is, sorry, there is a mistake. Let's correct this up. The calculation you have to be very much aware of. 6.0000, we have 0.0745. yeah, now it's 5, 9, 9, 9 and 10. So how much you will get? 5, 5, 2, 9.5. So it is equal to 5.93. 5.93. We have to find out molality. We got the value as 1/m. So molality is equal to 1 divided by 5.93. So if you calculate 1 divided by 5.93 is 0.1000. Okay. No, here if it is yes, if it is 10, then it will go by 1, right? It will go in 1. Okay, so we have put the decimal. Now it becomes 10, so it will 1 times, so 5.93, so we will get nearly equal to 4 point something. So again 0.168, we will be getting the value as 0.168 molar. So if you go on the calculation, we will get the value as 0.168, and hope this is clear. And see students, by using this equation it has become so easier. If you use the normal equations to find out the molality, then it will be very difficult to find out. It will be a very lengthy process. So in order to avoid that, in order to shorten that lengthy process, we are using this formula. Okay, right. Now let's do the another one. Calculate the molality. So the molarity is given as 3 of NaCl is the solute, and density is given as 1.25 gram per ml. Okay. Now what is the molar mass of NaCl? Molar mass of NaCl is 23 is the molar mass of gram atomic mass of sodium plus 35.5, that is equal to 58.5 is the molar mass. Now let's see. Here we are given that the number of moles is equal to, right, the molarity is equal to, we know that number of moles by volume. That means we normally consider it in 1 liter. So you can write it as it is equal to 3/1. How? Because if the value molarity is equal to 3, what does that mean? It means 3 moles in 1 liter. 3 moles in 1 liter. So from 1 liter of solution, 3 moles of NaCl is present. That is what 3 molar means. So this is how the concept works. So if you know the concept of molarity, then only you can identify that the NaCl is 3 moles given. Okay, so what is molarity? Molarity is the number of moles of solute in 1 liter solution. So if you consider 1 liter solution, then if the molarity is 3, then obviously the number of moles will be 3. Okay, so number of moles of NaCl is equal to 3. So I have to find out the weight of NaCl. So how to find out the weight? We can find out the weight that W2 by M2 is equal to 3. You know that weight by molar mass equal to number of moles, and M2 value we have found out that it is 58.5. So W2 equal to 3 into 58.5. What is the value there? Let's calculate here. 58.5 into 3, that is 15, 24, 25 to 15, 17. So it is 175.5. So weight of NaCl is 175.5. Do we need the weight of NaCl actually? Let's see. The density of solution is equal to molarity into, yes, molar mass, right? Molar mass divided by 1000 into plus 1 by m. So actually we do not need W2. Okay, so let's apply all the values given here. The density is equal to 1.25 and molarity is equal to 3. Then what is molar mass? Molar mass is 58.5 divided by 100 plus 1 by m. So let's do it in the next page. So 1.25 equal to 3 into 58.5 by 100, 58.5 by 100 plus 1 by molality. So I'll take this 3 to the LHS. So it will become 1.25 by 3 equal to 58.5 by 100 plus 1 by m. So 1 by m is equal to 1.25 by 3 minus 58.5 by 100. So it will become 125 minus 58.5 into 3, that is 15, 24, 25, 15, 17. It is 175.5. Okay, so it is 175.5 divided by 300. So it is minus 50.5 divided by 300. See, in the concentration terms, we need not have to focus on this minus, right? So just find out the answer here. You can just directly divide it. So nearly you will be getting the answer as, yes, 0.358, 1.25 divided by 58.5 by, here it was 1000. This was a mistake. Sorry, this was a mistake. This was a mistake. Okay, now let's make it clear. It was a big mistake actually. In the equation we have given 1000 here, and while rewriting it I made a mistake that I have given it as 100. Just check it here. Yes, here also here we have written the right one, and by rewriting here I have made a mistake that it should be 1000. Okay, now let's see. That is 1.25 divided by 3 minus 0.0585. So what is 1.25 divided by 3? You can divide by 3, so it will become point. So 12 means it 4 times will be 12, and now 5, it is 0.41, right? It is 0.41. So 0.41 minus 0.0585. Okay, 0.4100 minus 0.0585. So here you can make it as 3 here it is 10, here 9, here again 10. So 5, 1, 5, 3. So it is 0.35. So 0.35. So what is molality? Molality equal to 1 by 0.35, that is equal to 2.79 molal. Yes students, this is how you have to calculate. So be careful while shifting the pages or while rewriting the equations. So 1 0 have created a problem here. So we luckily we have find out the mistake and we have corrected it. So I hope this is clear for you. Now we will move on to the next one. Okay, the second one is normality. No, the third one is normality. We already have discussed about the molarity. We discussed about the molality. Now we are going to discuss about the normality. So let's see the definition. It is defined as the number of gram equivalents of the solute in 1 liter of the solution, and it is denoted by N. So what is gram equivalence actually? So gram equivalence, how can we find out the gram equivalence? So see, the normality equal to number of gram equivalents of solute by volume of solution. So what is gram equivalence? Gram equivalence is equal to mass of solute by equivalent mass of solute. See, gram equivalent is equal to mass of solute by equivalent mass of solute. Now we want to know what is equivalent mass. So equivalent mass is equal to molar mass of solute by N. This N is called as valency factor. It is not the number of moles, it is valency factor. Okay, so here the equation is simple. Now normality is equal to number of equivalents divided by volume in liter. Okay, so number of equivalents and number of moles are equal in certain cases, or you can consider it as number of equivalents is similar to number of moles. Okay, so that is what you have to remember. And how to find out the number of equivalents? It is by weight of solute divided by equivalent weight of solute. Okay, equivalent mass of solute. So weight of solute divided by equivalent weight of solute will give you the equivalence. So now we have to find out what is equivalent mass. Equivalent mass, or E2, is equal to molar mass M2 by the valency factor. So this is how you have to find out the value of E2. Now the thing is, we have to learn what is valency factor. So let's check what is valency factor. Let's see here. Dear students, if you are considering a solution, a basic solution or an acidic solution, what will be the valency factor for acidic solution? See, it is the number of H plus ions donated by the acids. If you are considering HCl, we know that HCl consists of one acidic hydrogen, so the valency factor of HCl is 1. If you are considering H2SO4, we know that H2SO4 can donate 2 H plus ions, so the valency factor is 2, and that means it can give off 2 hydrogen ions present in it. Okay, now what about the ortho phosphoric acid? It consists of 3 H plus ions which can be replaceable. It consists of 3 acidic hydrogen. And here in the case of H3PO3, there is a tendency for students to generally think that in H3PO3 there will be 3 H plus ions. No, actually the structure of H3PO3 is like this. O, O and O with H here, and H here. This will be double bonded O. Yes. This is how the structure of H3PO3. Here this hydrogen and this hydrogen is acidic because they are attached to more electronegative atom. But this hydrogen is not acidic since the electronegativity of hydrogen is 2.1 and phosphorus also nearly equal to 2.1. There is no much difference in electronegativity. So this hydrogen is non-acidic. It cannot be replaceable. That means H3PO3 consists of 2 acidic hydrogen. So its valency factor is equal to 2. So these are the values you have to learn. Okay. Now let's move on to the next one. Now if in the case of base, what is the valency factor of base? Valency factor of base is just the number of how much OH minus ions can be replaceable from a base. See, if you are considering NaOH, then one OH minus ion can be replaced. So the valency factor of NaOH is equal to 1. If you are considering calcium hydroxide, then 2 numbers of OH can be replaced. Okay, 2 OH minus can be replaced. If you are considering AlOH thrice, then 3 OH minus can be replaced. That means the valency factor of AlOH thrice is 3 and valency factor of CaOH twice is 2 and valency factor of NaOH is equal to 1. Now the equation, this equation we have already studied, that normality is equal to weight of solute by equivalent weight of solute into volume of solution in liter. If we are considering it in ml, if the volume of the solution is given in ml, then you can write it as weight into 1000 divided by equivalent weight into volume in ml. Okay, so how to calculate equivalent weight? We have told that equivalent weight is equal to molar mass by valency factor. This is called as valency factor, and we have just learned how to measure or calculate the valency factor. So now we can say that normality is equal to N into molarity. What does that mean? N means, it means valency factor. So this is very important. This is very important equation, that normality is equal to valency factor into molarity. Okay, yes. Okay students, so this one you have to by heart. This normality is equal to, normality and molarity can be connected, that is normality is equal to valency factor into molarity. Okay, if in certain questions you will be given with molarity and you will be asked to find out the normality, in such case you can find out the normality by multiplying the molarity into valency factor. Hope this is clear. Now we will move on to the next one. See, the normality and molarity equation. This equation is very important, and this equation you will be using in states of matter as well as in equilibrium also. Okay, where more than one acid or one base is intermixed, and you will be asked to find out the pH or the H plus ion concentration of the resultant solution. So in such cases you have to calculate this. Okay, you will be using this formula. So just read what it is. If a solution having normality of N1, see, I have a solution and the solution, the concentration of the solution is N1 normality. Okay, and the corresponding volume of the solution is V1. And if I add more water to this, okay, if I add more water to this, and if you add a water to a particular solution, what happens? The concentration will decrease. That means the volume gets diluted, right? So the volume gets increased to V2. So in accordance with that, in accordance with the change in volume, there will be the normality also will get changed to some other value. Here you have to understand the equivalence present in the first container and the equivalence present in the second container, both are same. So here by understanding or by hearing to the term equivalence, you will not get the point. So I'll explain it in the number of moles. See, I have a container where I have added 2 moles of NaCl. Okay, 2 moles of NaCl. So it consists of 2 moles of NaCl and it consists of 10 liter of water. Let's say 10 liter of water. Then I add again another 10 liter of water. The concentration will change, sure, no doubt. But does the number of moles changes? Does the number of moles of NaCl changes? No. We have already added 2 moles. That 2 moles will always be present inside that solution. If you add more water, what happens is that the concentration decreases, but the number of moles never changes. Similarly, I have already told that number of moles is equivalent to gram, the gram equivalence is equivalent to number of moles. So once you have added certain gram equivalence of solute, then if you add more water or if you increase or dilute the solution, the gram equivalence remains same. So that means the gram equivalence in the first case, how to calculate gram equivalence? That is equal to normality into volume. Normality into volume will give you the gram equivalence. So the gram equivalence means gram equivalence is equal to normality into volume. How did I get that? Because we have studied that normality equal to gram equivalence divided by volume, similar to that of molarity and number of moles. Okay, gram equivalence by volume gives us normality. So we can say that gram equivalence is equal to normality into volume. So that means the first case and the second case, the gram equivalence is same. So we can write it as N1V1 is equal to N2V2. Hope this is clear, students. Okay, now we will move on to the next one. See, similarly, we can relate the molarity and volume equation. Let's see here. Here, I have a solution with certain amount of V1 volume, and I have added some certain number of moles of solute. So let's see, N1 number of moles of solute is added. And we know that if I add more water, then what happens is that the volume increases. Similarly, the concentration decreases, right? Here the volume get increased. So what happens? If the volume is increased or we are diluting the solution, what happens? The concentration decreases. Okay. What is the concentration? Concentration is molarity. Here we have M1 and here we have M2. So let's see. We know that molarity means number of moles by volume, right? So what is number of moles? Number of moles will be equal to molarity into volume. This is a very interesting equation. So we know that for the first solution and for the second solution, the number of moles will be same. So we can write that number of moles is equal to M1V1 and that is equal to M2V2. So from this relation, we can say that M1V1 is equal to M2V2. It is another important relation regarding the molarity and volume. So M1V1 is equal to M2V2. How we got that M1V1 equal to M2V2? It is from this solution. We know that if you are only adding water to a solution, then the number of moles of solute will not be changed. It remains unchanged. Okay. So the number of moles of solution from the first case and in the second case both will be same. So we can say that M1V1 equal to M2V2. Okay. Now let's see a question that calculate the molarity and normality of a solution of oxalic acid containing 12.6 gram of acid in 500 ml of solution. Can you do this, students? Can you do it by yourself? Yes. Let's check this out. Here you are asked to calculate the molarity and normality of the solution of oxalic acid. Let's see the oxalic acid. Here it is COOH twice 2H2. So let's calculate the molar mass of the solution. We know that carbon, there is 2 carbons in COOH. We can calculate the mass of COOH. We know the mass of H2O is 18. Here it is 18. So 2 into 18 is 36. So this part we got the answer as 36. Now this part we have to calculate. Here we know that the mass of carbon is 12 and there is 2 oxygen, that means 32. So 12 plus 32 plus 1, that is 44 plus 1, 45, and 45 into 2, because since it is COH twice, 45 into 2 is equal to 90. So we get it as 90 plus 36, that means 126 gram per mole. Okay, that is the molar mass of the solution. Now weight is given. Weight is given, that is 12.6. Okay, weight is given as 12.6. So we can find out the number of moles. Number of moles is equal to weight by molar mass. That means weight is equal to 12.6 divided by molar mass 126. That means the number of moles equal to 0.1. So now we can find out the molarity, that is 0.1 number of moles into 1000 divided by volume of solution. Volume of solution is 500. Why I used 1000? Because the volume of solution is given in ml, right? Now we can cancel this and this. We will get it as 2. So molarity equal to 0.2. So we got the value of molarity as 0.2. Now we have to find out the value of normality. We know that normality is equal to molarity into valency factor, right? So let's find out what is the valency factor of carboxylic acid or oxalic acid. We know that from one molecule we get 2 H plus ions. So we can say that the valency factor here is from one COOH, see this is how it is, COOH. So from one OH here we have one H plus will be released and one more COH is present. So in total we will getting 2 H plus. That means it comes, the valency factor here is 2. So molarity is equal to 0.2 into valency factor 2. So 0.2 into 2 is equal to 0.4. So the normality is equal to 0.4 and molarity is equal to 0.2, and that is the answer for this question. Okay. Now dear students, the last term, that is mole fraction. What is mole fraction? It is the ratio of number of moles of a particular component to the number of moles of a solution. Okay. So let's see, I have a solution. And this solution consists of two components, one is A and one is B. Okay, I have to find out the number of moles of A. Then what is normally we calculate the mole fraction in terms of chi, or for convenience we call it as X. So mole fraction of A is equal to, I have to find out the mole fraction of A. Then mole fraction of A equal to number of moles of A divided by total moles, that is Na plus Nb. Similarly, I can find out the number of moles of B or the mole fraction of B. Mole fraction of B equal to number of moles of B divided by total number of moles, that is Na plus Nb. And this relation you have to learn by heart, that is the total mole fraction of a solution will always be equal to 1. It can neither greater than 1 nor it can be less than 1. It will always be equal to 1. So in one more case, I will teach you that if I have a container or a solution where there are three components, let's say there are three components A, B and C. So if I am asked to find out the mole fraction of A, then the equation will become number of moles of A divided by total moles. Here total moles means Na plus Nb plus Nc. Similarly, I can find out the mole fraction of B and mole fraction of C, right? And you can use this relation, that is mole fraction of A plus mole fraction of B plus mole fraction of C equal to 1. Okay students, so this is all about the mole fraction, right? Yes. Now another question. See, a solution contains 2.5 mole of ethanol and 7.5 mole of water. Calculate the mole fraction of each component. Now we have to find out the mole fraction of C2H5OH, that is ethanol. So mole fraction of ethanol is equal to number of moles of ethanol divided by total moles. What is the total mole? Number of moles of ethanol plus number of moles of water. So we know that ethanol is 2.5 and total moles is 2.5 plus 7.5, that means 10. So 2.5 by 10 equal to 0.25. So the mole fraction is 0.25. Now instead of using the same formula for water, we can use another formula. So let's check this out. I'll teach both the way. You can use it as number of moles of water divided by total moles. Total moles is 10, we know that. Now number of moles of water is 7.5. So 7.5 by 10 equal to 0.75. This is the ordinary method. So once you know the mole fraction of one component, then the second one you can find out by this formula, that is XA plus XB equal to 1, right? So what will be XB? XB equal to 1 minus XA. That means 1 minus 0.25 equal to 0.75. So thus this one is the easiest one to do. So once you find out the mole fraction of a component, then the second component, mole fraction of the second component can be found out by using this formula, right? Hope this is clear, students. Now we have dealt with all the equations dealing with four concentration terms, that is molarity, molality, normality and mole fraction. Now this is another important relation, that it is the relation between molality, moles and mole fraction. So you have to learn this. Molality is equal to number of moles of solute. This is number of moles of solute. Number of moles of solute into 1000 divided by, this is number of moles of solvent. Number of moles of solvent. Number of moles of solvent into molar mass of solvent. See, always remember that if I am giving you 1, then it simply means that represents the solvent. If I give you 2, then I simply mean it represents the solute. Okay. And this is another equation, that is molality equal to mole fraction into 1000 divided by mole fraction of 2. That is the mole fraction of solute into 1000 divided by mole fraction of solvent into molar mass of the solvent. So this equation is very important, and here there is a note. This note is all about where you have to use this equation or this formula, that is in case of a solution of 2 liquid solution. Okay, the liquid with more amount of moles or mole fraction is taken as solvent. So always consider that if you are considering a solution which is made by mixing 2 different solvents, then the solvent having lesser number of moles or the solvent having lesser mole fraction value, that is considered as a solute, and the solvent which is having more number of moles or the solvent which has the more number of mole fraction, it is considered as the solvent. Okay students, so that point you have to remember. Okay. Now about our crash course, you will be getting 90 plus classes from our crash courses, and the duration will be till to the date of your exam, and the syllabus will be covered by the JEE experts, and we are using flipped classroom method by adopting a mentorship program along with that, and you will be having a proper doubt solving session also, and this all together we are giving in our crash course program. And there is a subscription plan, and you can select a subscription plan that suits you better. We have 2 subscription plans, that is one is Smart and the other is Profi, and you can see that what are the features of the subscription plan. There will be interactive live classes, and there will be structured courses and PDFs, and you will be having live tests, and physical notes will be provided, and one-on-one mentorship. See students, while if you are a repeater or if you are a going students, like if you are a +1 student or +2 student, you have to understand that in the early days you will be having more energy, or you will be so enthusiastic towards studying. But as the spirit moves on, gradually your energy comes down, gradually your enthusiasm comes down, and you will be feeling of sitting idle without studying. Studying becomes more more boring, and in such times you always require a hand to hold your hand and take you from that pit and pull you out from there and motivate you to work harder and to run towards your goal rather than stay idle. So that's the more important feature that we have a one-on-one mentorship. And also, if you have any doubts, we will be having a live doubt clearance sessions, and also mock tests. See students, mock tests are very, very important if you are preparing for competitive exam, because you have to increase your accuracy, you have to increase your problem solving skill, you have to increase your problem solving speed, and you have to increase your reading capacity. You have to read it, you have to understand it by a single reading. So for all these things, you should have to appear for regular mock tests, which will help you improve your capabilities. And also we will be having additional special courses, and this is all about our JEE special subscription plan. And if you are wishing to join us, you can join in you can take any of the subscription plan which will suits you better. Okay, now I have already told you we have a split method, right? We have a split method education system here. just I have mentioned here, you can see here that yeah, the previous slide I've told you that we have a flipped classroom method, and the flipped classroom method is all about this one. Yes, we will be giving you a theory session which contains all the important concepts, which contains all the important theories, which consist of all the important things in that, and along with the study materials you will be having, and we'll be giving you certain webinars, and along with that homework, and also we'll be checking the homework. Homework check will be done by the Altered Academy, our academies. Okay, so this all will be given to you, and this is what you will have in our packages. So in the next one, we have a special price for the smart plan, that is, we will be given all these courses for 2,990 rupees instead of 8,000. Okay, so 7,990 is the normal cost, so we will be giving you for 2,990. And okay students, we will be waiting for you. So let's listen to the classes, and in the YouTube we are giving you the free classes. So hope today's session was fine and it was interesting for you, and we'll meet in the next session. Okay students, thanks a lot.